so solve quadratics, unit 3, lesson 5. So there are some key characteristics of a quadratic, the vertex and the x-intercepts or the zeros. So any quadratic or parabola has a vertex, right? And the word problems are usually going to say some keywords like highest, lowest, or maximum or minimum to know that you're going to solve for vertex. And other situations usually lead you to finding the x-intercepts, and there might be 0 or 1 or 2 of them, depending on what the graph looks like. And so for question 1, if the quadratic word problems doesn't ask for maximum or minimum, then the question often reduces to finding the x-intercepts or the zeros of the quadratic. And so when you're trying to solve for the x-intercept of the quadratic, so the related quadratic that has one side 0, what that means is the other side of the equation must equal to 0 and for you to continue to solve for the x-intercepts. So let's look at this example. The hypotenuse of a right triangle is 6 centimeter more than the shorter leg. The longer leg is 3 more than the shorter leg. Find the lengths of all 3 sides. So let's draw our right angle triangle. Okay, and highlight some key features. So we have the hypotenuse that is 6 centimeter more than the shorter leg. All right, so that means, reminder for what a leg is and where the hypotenuse is. If you look on my side notes on the right, this is a right angle triangle, a typical right angle triangle, and the side that is across from the right angle is always the hypotenuse, the longest side of a right angle triangle. And it has to be a right angle triangle for there to be a hypotenuse. And meanwhile, you have the other parts, which are the legs. You have one leg and then the other leg, okay? And so it says the hypotenuse of a right angle triangle is 6 centimeters more than the shorter leg. So if I set this side that looks kind of short to be the shortest leg, okay, meanwhile, the hypotenuse of a right angle is 6 more than, so how am I going to express that? Well, 6 more than is x plus 6. Right? So the shortest leg plus 6 will make up the hypotenuse. So hypotenuse. Okay, meanwhile, let's keep going. Longer leg is 3 more than the shorter leg. So remember, the hypotenuse is not part of the leg, right? It's only the other 2 parts that is the leg, right? And so that means the longer leg must be this part, is 3 more than the shorter leg. And so that means I have x plus 3, right? So this is the longer leg. All right, so let's put that together. So on this side, I have my Pythagorean theorem, which is a squared plus b squared equals c squared. And it doesn't really matter what you set a or b as, right? Because that's just the other legs. But what's important is that the hypotenuse is plugged in as c. And whenever I see binomials or anything higher than a monomial, I usually put the brackets so I don't make any mistakes later on. So let's plug in. So let's say I say a is a longer leg, so I have x plus 3 bracket squared. If you don't do the brackets, you're not going to do distributive properly and you might get it wrong. So, okay, plus x squared equals x bracket x plus 6 close bracket squared. All right, next. So on the side notes, I wrote what a binomial theorem is. So based on binomial theorem just means that I write the a plus b twice. I should get it FOILed out, and I get a squared plus 2ab plus b squared. And with more and more practice, you'll get straight from the yellow to the green arrow that leads to the yellow, okay? So we want to go right there right away, otherwise it might look really busy. Just wanted to put that on the side so you know where this is coming from. So I'm going to rewrite, and I get this step to FOIL out. So it's basically x plus 3 bracket times x plus 3 bracket. And so when you FOIL it out and collect the like terms, you will get x squared plus 6x plus 9 based on the binomial theorem. plus x squared. Do the binomial theorem again on the right side. Then you get x squared plus, what I'm thinking in my head is, okay, my a is my x, my 6 is my b, and then I have to multiply that by 2. So that's 12x plus 36. All right, I'm getting closer. In order for me to solve, I need to get that one side to equal to 0. I'm paying attention to this. All right, and so that means I need to start moving things. I'm going to move everything to, let's say, the left. So that means I need to put the, get rid of everything on the right by getting rid of it by using the opposite signs. And so what I do to the right side, I have to the left. And so I get negative 6x plus, plus 9 minus 36 is minus 27. So minus 27 plus x squared equals 0. I usually write it so that it's highest to lowest degree. So it's x squared minus 6x minus 27 equals 0. So far I have written the standard form of my equation, and I set up my equation for part 1, question 1. Question 2. There are 3 ways to find solutions for the independent variable on the quadratic type question. What are they? So in terms of that question, number 2, I had gone through question 10b of the homework from Unit 3, Lesson 3. So it's right over here. And I go through ways that I could solve for the variable. So when I have a quadratic formula like this, it's in standard form, and I need to solve for x. And there are 3 ways that I could go about. One, I could try to factor it. That way I could see where what my factors are, and therefore find my x-intercept that way. Second, I could use the quadratic formula if my factoring doesn't work out. And then in this case, well, the y value is equal to 0 already. And then I would try to get x by itself. And in order for me to do that, I would have to make sure that it is in in vertex form. All right. So let's go through it for this question. At least let's write down question 2. So question 2, in summary, the first method is to do factoring. Second method, do quadratic formula. And it always works. However, it's not my favorite method because it's not very quick. But for word problems, we might see ourselves use quadratic formula more often, maybe because there's decimals involved and whatnot. So usually I would try to factor first, and if it doesn't work, use the quadratic formula. But it does always work, unless you have one of the scenarios that I mentioned at the beginning, which was, well, when you have this going on or that going on, you're not going to get x-intercepts because there are none. That's when you have like the discriminant being the negative. Discriminant is the number under the square root. Okay, so 3. The third way that you could find the solution is BEDMAS backwards. And this only works if variable appears once. Well, what that means is that you're basically in vertex form. Factored form, you have 2 x's that appear. Standard form, you have x's appear twice. Vertex form is the only method where x is by itself. Like it's let's say this is like a typical vertex form, right? X is by itself. That's what I mean by that. Right? And then you would go BEDMAS backwards, meaning move that over, etc., etc. Okay, but we're gonna go through this question, so no need. All right, so method 1. All right, so number 3, solve the above problems problem showing more than one method. So let's do method 1. So I have x squared minus 6x minus 27 equals 0. Okay, I need to solve for x. I don't need to find the vertex because there's no mention of max or min. Okay, so method 1. Reminder is you're trying to factor. Okay, so I'm going to write x squared minus 6x minus 27 equals 0. Okay, factoring. So if you know how to factor it, go ahead and go through it and then pause and then fast forward, okay? So the way you factor, I'm going to do the crisscross method. What are the numbers I multiply to 27? So 27, it's 1 and 27, and 3 and 9, and there are no more, except that I need to consider the negative, which is on the 27. So that means I need to have a single negative on one of the numbers. So either on the 1 or the 27, or on the 3 or the 9 to make it equal to 27. Meanwhile, the number has to add up to -6. So right away I can see that's not ever going to add to a -6. But I look at the 3 and the 9, and if I subtract it somehow, I can get a 6. So that means that the 9 will have to be the correct one because 3 minus 9 is -6. And meanwhile, I put little ones here because 1x times 1x is equal to x squared. So in summary, I have x plus 3 and then x minus 9 is equal to 0. So remember that my x-intercepts are x equals -3 because that bracket, when x is equal to -3, all of this is equal to 0. And therefore, the whole thing becomes 0, right? And so that's why I have x equals -3 as one of my x-intercepts, and then x equals 9 as my other x-intercept. But let's take a step back. So this was a word problem dealing with lengths of a triangle, meaning that you have to consider if some answers don't make sense. You can have 9 centimeter, 4 or meter in terms of dimension, but you cannot have a negative. And therefore, I'm going to write negative length doesn't make sense. Okay, so therefore, x equals 9 is the only x-intercept that I'm going to grab. Okay, so that's kind of like the change because now we have to interpret the situation, right? Okay, so that was method 1. I still have to write a summary because I'm not done because I need to write down, I have to find the lengths of all 3 sides. All right, so let me write a summary first. So therefore, since x equals 9, that means one of my lengths, the shortest leg, is 9 centimeters. And then my second, the longer leg is x plus 3. So that means that is 9 plus 3, which is 12 centimeters. And then x plus 6, which is hypotenuse, that means 9 plus 3 is equal to 15 centimeters. So that means, therefore, the lengths of the triangle sides are 9 centimeter, 12 centimeter, and 15 centimeter. Okay, so just in case, we're going to go through the other methods because they've asked us to use more than one method. So method 2. Method number 2 requires us to do the quadratic formula. Quadratic formula. All right, so its quadratic formula is x equals -b plus minus square root of b squared minus 4ac over 2a. So don't be afraid to use that function on the calculator if you know how to. Go into mode, equation, degree, and then 2, and then fill in your A and the B and the C as a quick way to do the quadratic formula. So know how to do it algebraically, like manually by hand, and also using a calculator if possible. So when I plug it in, so I plug B as a -6. I'm reading the green, and then A is 1, C is -27, and then A is 1. So I plug that in, and I did it a little in advance, and I get 6 plus minus 12 over 2 when I do that, which ends up further simplifying to. Basically, you have 6 plus 12, which is 18, and then 18 divided by 2 is 9. So you have x equals 9 as one of them, consistent with our previous method. And then 6 minus 12 is -12. -12 divided by 2 is, so 6 minus 12 is -6, and then -6 divided by 2 is -3. And that one still doesn't make sense. Okay, I'm not going to rewrite the conclusion. I'm just going to put an arrow there. So we're just working on the algebraic parts. Okay, and then we're going to go to method 3. So method 3 requires us to get the variable to appear once. And so that means that we need to do what? Because right now we're in the quadratic form. So let's write method 3. And it said to use BEDMAS backwards. Okay, so basically, because my equation is x squared minus 6x minus 27 equals 0, my x does not appear once. And so I need to, one, complete the square to get to vertex form. And then I have to do BEDMAS backwards. Okay, so on this side, I copied and pasted a completing the square example with the steps so you can remind yourself of a more thorough step. So let's see. First step, put the first two in brackets. And I don't have any a value to the x squared, so that part is relatively simple because I didn't have to take anything out. Second step says I have to do the b over 2 step. And I get -6 over 2 squared, which is -3 squared, which is 9. So that is a number that I'm going to add and subtract within here, because I'm not really changing anything if I'm adding 9 and subtracting 9 to help me get to completing the square. Because I want to introduce that vertex at the end. Okay, so right here. According to my steps, I need to take out the -9, and so I will. 0 is equal to. All right, remember that I've said previously that this right here, the b over 2, ends up helping us when we're trying to factor. Meaning, as my next step, when I'm trying to factor this part, the two numbers that multiply to +9 and add to -6 is -3, just like the yellow highlight. And so I get 0 is equal to x minus 3 squared, and then minus 36. All right, sadly I'm not done because that was just part 1 of method 3. So I need to do BEDMAS backwards. All right, so that was part 1. Part 2, BEDMAS backwards. Okay, so I basically need to get x by itself. So that part's not too bad. Okay, I'm just going to rewrite it. I'm going to get x by itself, doing BEDMAS backwards, meaning I need to do addition and subtraction first. I need to get rid of that -36 by doing the opposite sign. To get rid of -36, I'm going to add 36 to both sides. I get 36 is equal to the following. I want to get x by itself, but there is a squared along the way. And remember, this is within a bracket, right? And that means I can't touch it. Brackets is the last part of BEDMAS, right? BEDMAS backwards. And so I'm going to square root both sides. I always get a plus and minus version. And square root of 36, that is a perfect square. So I'll get plus minus 6 exactly on the left side. Meanwhile, these parts will have canceled out because if you square root a square, that part cancels out and you get x minus 3. You're almost done. You're going to add 3 to both sides and you get x is equal to plus minus 6 plus 3. Let's break that down. Plus 6 plus 3 is 9. Negative 6 plus 3 is equal to negative 3. Does x equals negative 3 make sense? We said it doesn't. And we get x equals 9 again. So that's the other way, method 3. Although method 3 took us a long time this time, reason I'm going through all 3 methods is because what if you were given the vertex form right away? Then it's going to be the easiest to go to method 3, right? So it depends on what you're given. If you have an equation that's factorable like this time, then you're going to factor first. If you're given an equation that's not factorable, you might want to try to factor first and then go to quadratic formula. So we're given, we have all these 3 methods because we're going to use a certain method depending on what's useful for that scenario. Okay, it's a pretty big question, so just a heads up. This is a diagram of a practice field. The track and field coach wants 2 laps around the field to be 1,000 meters. 2 laps to be 1,000 meters. But the phys ed department wants the rectangular field to be as large as possible. As large as possible. What dimension would satisfy both conditions? Okay, let's write down a couple of things. So when I get these kind of questions, I usually like to label the diagrams and write down some probable equation per se. All right. So first off, one thing is they told us the perimeter of this composite figure. So the perimeter is the distance around the outside, and they said that 2 laps is going to be about 1,000 meters all around, right? So that means 1 lap is going to equal 500 meters. That's my first information that I know. Let's break that even further. So then that means, let's say I give this part, because there's a rectangle and a circle, 2 semicircles that make up this shape. So let's say label this as x. So that's like the length of the rectangular figure. And then this is a circle, so I'm going to label that as r, label that as r. And so all the way through, that's going to be 2r. Okay, so I've kind of labeled the figures. How is that going to help us? So let's break down the perimeter. So that means that if I go all the way around, I have 500 meters. But I have, let's see, I have this part basically. And how many do I have? I have two of the length. Two times the x. Okay, and then I have the other part, which is here. And when we reflect where that is if we put 2 semicircles together, that makes a full circle. That means I need to find the circumference of the circle. And the circumference of the circle, the formula is this. And so I'm going to put that together and I'm write, okay, 2x plus 2 pi r. Let me write down that in words. So that part, well, I'll just use a highlighter to help you distinguish it. So that part is this, and then this part is this, and where 2 pi r is the circumference. Okay, so that's one piece of information that we know. We also have some information about how we want the largest possible rectangular field. So when you see the word large as possible, a couple of things should be ringing in your head. One is if I want a large field, that means that I'm dealing with not perimeter, but area. I want the field, like the amount that the space that it takes up to be large. And so that means I need to try to set up an equation for the rectangle, right? So I have A equals length times width. All right, so let's plug in with the variables that we're using. In this case, the length of the rectangle is x, length being usually the longest side of a shape. And then the width is 2r. All right, so I have A equals x times 2r. So I have these two equations so far. So let's back up a bit. What do you think I can do at this point? I have two equations, and I need to find like a large area. And so my goals are, these are my goals to help me get there. Right now I have too many variables going on. I have the x, the r, and the a. Is there any way that I can get two variables? And then next is they use the word large, which means that I am needing to make a quadratic where I'm solving for the maximum. All right. So what I'm going to do is I'm going to try to isolate for a variable here. Okay. So I'm going to try to get a variable by itself, and so that maybe that I can plug it in into the other equation, and I might have a simpler equation to work from. So it looks like x is more simpler to solve for because all I have to do is move something around and then divide by 2. So I'm going to go ahead and do that. So 500 equals 2x plus 2 pi r. Subtract 2 pi r on both sides. And then you get 500 minus 2 pi r equals 2x. I want x by itself, so divide by 2 on both sides. And x is equal to, not 500, but that simplifies. Because they're both even numbers, right? The 500 and the 2. So I should simplify it. 500 divided by 2 is 250. And then 2 pi r divided by 2 is 2. Sorry, 2 pi r divided by 2 is minus pi r. All right. And what do I do with that? Well, I'm going to sub in here and see what happens. All right, so I have A equals bracket 250 minus pi r times 2r. So right now it's in factor form. That doesn't really help us in this case because I want it potentially in the vertex form because I want it to be, I want to find the max, right? Maximum means I need to get the vertex form. And so I gotta do distributive property. So I have A equals 500r minus 2 pi r squared. So that means I'm in standard form. I want to now get to, okay, so I went from factored. I'm going to standard. And I have to eventually get to vertex. So let's do that. So I should have the ax squared, the negative 2 pi r squared at the front. So that it might be easier to organize. Okay, and I need to take this part out. And so I'm going to divide both by negative 2 pi. So we always take the a out of ax squared when we're trying to complete the square. So we get r, oh, I don't have r squared yet. I have to show that I take out negative 2 pi. That doesn't disappear suddenly. So the negative 2 pi is pulled out. And inside I have r squared minus 250r over pi. Okay, and then, so this is like a more complicated version of the completing the square. All right, so my rough work being b over 2 squared. Okay, I have my negative 250 r over pi. That's the same thing as if I times it by 1 over 2 squared. And I'm going to try to simplify. The 2 becomes a 1, 250 becomes 125. And so what I have is a negative 125 over pi squared. So instead of me expanding that out per se, I might just keep it and work with it. And so I keep in mind that this and this are the same thing, because if I take that negative out of the bracket because it's squared, I really have this, okay? Because negative times a negative is a positive, so they're kind of simultaneously existing. They're like the same thing. All right, so I have a equals negative 2 pi bracket r squared minus 250 over pi. This is the value I'm going to add and subtract. So I'm going to add 125 over pi bracket squared. I'm going to subtract 125 over pi squared. And then another bracket. Okay, need more space. And so I need to take that negative version out of the brackets after I multiply it by the negative 2 pi. Okay, so I have a equals negative 2 pi bracket r squared minus 250 over pi. At this point, I'm going to expand that out. 125 squared is equal to 62,500 over pi squared. And then I get that out of the brackets. So what I have is negative 2 pi times negative 125 over pi bracket squared, something like that. All right. Okay, so remember from some simpler completing the square that this is going to be what my factor is. So double checking, so yeah, negative 125 over pi squared is going to be that. And it is going to add to this. And so I've done the double check. So I'm going to do it. So a equals negative 2 pi bracket r minus 125 over pi close bracket squared. And then we need to simplify this. Okay, I'm going to simplify that on the side. I have negative 2 pi times 125 is, so that's going to be negative 15625 over pi squared, because basically this would have been all positives, but then there's a negative there, and so that's why. There's parts that cancel out, and this would be 31250 over pi. Okay, that's my rough work, so that I can just write plus 31250 over pi. So if this was not a word problem, you could probably just keep it like that. But in a word problem, it might make more sense if we keep it as decimals. So it's a real life word problem. It's a word problem, and so let's see. We're going to have a equals, the approximate one that we have is negative 2 pi. So 125 divided by pi is approximately 39.8. And the optimum value is about 9,947.2. So the vertex is, so remember, these are all in terms of r, like the value, the input that we're discussing is r, whereas the output is a, and therefore my vertex is 39.8, 9,947.2, where this is the r and this is the a. All right, almost there. So I need to write down what the dimensions are. So I'm going to add an image of the diagram right here. Okay, so then I could kind of look at the diagram as we go, right? So I have, therefore, dimensions are. Okay, before I summarize, unzoom a bit. Okay, good. Okay, dimensions are, semicircles should have a radius of 39.8. So semicircles should have a radius of 39.8 meters. Meanwhile, the length of the field, should be, well, how do we get that? When we unzoom, notice that we had solve for x over there. And so I'm just going to use that formula over here and write x is equal to 250 minus pi r. Maybe I should unzoom. And so x is equal to 125 meters when you plug that in about. And then for the width, I have 2 times r, which is about 79.6 meters. Okay, and so that is it. I'm just going to highlight where I'm talking about. So this is that. And then if I was to draw, use this. This is that. All right, that's question 4. Question 5, translating English into math problem. Find the 3 consecutive integers such that 4 times the number of all 3 is 2 times the product of the larger 2. We got to break it down. So 3 consecutive integers. So consecutive means when the numbers are in order. So 1, 2, 3, 2, 3, 4, those numbers are in order. And integers are positive and negative whole numbers. So I'm going to set, when I usually see these kind of questions, I write a let statement. So I write let x represent, let x be the, and the simplest way to put it is make the first number of the x the first. Let x be the first integer. And then you can let, well, how do you make the second integer? Well, if the first number was 1, what do you do to it to get the 2? You would add 1 to it. And so you would do let x plus 1 be the second integer. Okay, and then you would do what? Well, if you have 1, 2, and then 3 as a third number, then you would add 2 to the initial one. Let x plus 2 be the third integer. There's no point of introducing another variable to make it more complicated that way. But for consecutive, you just want to be as simple as possible and make your scenario. Okay, that's the first part. Okay, and then it says such that 4 times. Okay, and then it says the sum of all 3 is 2 times the product of the larger 2. Meanwhile, I'm going to break down what sum means. Sum means answer to addition. Is means equals. Times means times. Product means answer to multiplication. And then we can try to interpret it. All right, so it says 4 times. So I'm just going to write 4 times with the dot as the multiplication. The sum of all 3. So that means I have big square brackets. I have my x plus the x plus 1 plus x plus 2. So that is my yellow and green highlights. Right? And then equals is 2 times the product of the larger two. So I need to put big brackets. Product means multiply. Multiply the larger two expressions. So that's what I have. So in terms of highlighting, I have 4 times. That's that part. The green is sum of the 3. And then the blue, which is 2 times. And then the brown, the product of the larger two. All right, let's keep going. There are parts that simplify. This simplify. This, what happens to that? Well, there's FOIL going on, distributive property. So we got to simplify. So we have the 4, x plus x plus x. Well, they're all, there's brackets, but they're all being added. So that's 3x. 1 plus 2 is 3. Close brackets equals. All right, so 2 bracket. X times x is x squared. Plus x times 2 is 2x. 1x. And then plus 2. I'm going to simplify that. So it's 2 bracket x squared plus 3x plus 2. 4 bracket 3x plus 3. I'm going to keep simplifying by distributive property. And we have 12x plus 12 equals 2x squared plus 6x plus 4. All right, if you remember from previous, you're not really going to get anywhere if you like leave it like this and try to solve it, like guess and check or anything like that. You always want to make sure that when you're dealing with a quadratic equation, and that if you're trying to solve for x-intercepts or zeros, you have to make the other side equal to 0. So I'm going to try to move the least number of terms. So I'm going to move these and then write it underneath the respective like terms so it's easier for me to organize. So I have 0 equals 2x squared minus 6x minus 8. All right, recall, do I need to find vertex? No, I need to find the x-intercepts. I need to find the solutions to when this equation is true. Okay, recall the 3 methods of solving for your equation. So these were the methods. Okay, so these are the 3 methods. Yeah, okay, so the 3 methods were these. And the ones that are going to make sense. So do you want to use a quadratic formula right away? No, you shouldn't. You could, you'll get it right, but because things are time sensitive, we want to use methods that are quick. And I'm seeing pretty nice numbers, so I want to at least try factoring. And so I notice that they're all even numbers for the coefficients, so I'm going to factor out the 2 and then try to factor. What number multiplies to -4 and adds to -3? Well, these are the only factors of 4. And then in terms of putting a negative, I can put the negative on the 4. That way it adds to a -3 and it multiplies to -4. Okay, so it was factorable, and so I have 0 equals 2 bracket x minus 4 x plus 1. Breaking it down, that means I have x equals 4 and x equals -1 as my x-intercepts and my solutions to the question. So I should take this off right away, right? No, it's because the integers are positive and negative whole numbers. Therefore, x equals -1 is fine. And so because integers are positive and negative whole numbers. They're both fine. If I had a decimal, I would have to cancel that one out. But good news is I'm getting some right answers, and therefore the integers are, so that means if my first number was a 4, then my set of numbers are 4, 5, and 6. So that's one situation. Or if my smallest number is -1, add 1 to that, you get 0, and add 1 to that, you get 1. So those are the set of the consecutive numbers that satisfy the above. Question number 6. Okay, heads up for this question. It's a pretty big question again for question 6. Dan and Sue set off at the same time on a 42-kilometer go-kart race. So they're traveling the same amount because they're both going on this go-kart race, right? Okay, then Dan drives 0.4 kilometers faster than Sue, but has to stop en route and fix his go-kart for 1/2 an hour. So half an hour. And then this stop cost Dan to arrive 15 meters after Sue. How fast was each person driving? Okay, there's a lot of information being thrown at us. And when you're getting a question that deals with distance, speed, and time like that, I invite you to try to organize in a table if possible. Meaning some kind of T-chart where we can say that, okay, first we have Dan, we have Sue. And the parts that we're dealing with is distance, which is in kilometers. We have speed, which is kilometers per hour. And then we have time, which is in hours, right? And so sometimes it helps to use the pyramid, and you might have seen this in your science class. And the way I remember it is, okay, so I know the speed limit is always kilometers per hour. So that means if I put my V here, that means my distance has to be on top and my time has to be on the bottom because I have to have kilometers on the top divided by hours. So that's how I kind of remember it. Okay, and so let's fill in the chart based on what we're given. So the easiest part is, okay, they're traveling the same number of kilometers because they're both going on this go-kart race, and they're the same distance all the way around, right? So that's consistent. Let's go to the speed. So we have Sue, and we have Dan. Okay, so it's easier usually if you write one in terms of the other. And we have, let's say, Sue. And Sue is driving slower than Dan. Okay, so well, Sue is driving at 8 x kilometers per hour. Meanwhile, Dan drives, what do you think? X plus 0.4 kilometers per hour, right? And at that point, I'm going to write a let statement. Let X represent Sue's speed in kilometers per hour. Okay, next, time. Well, we don't really have a lot of information on time. And so that's when this formula is going to help us, okay? And so based on the pyramid, time is equal to distance over speed, right? With that in mind, if that is the case, that means how long are they each taking? Well, in terms of their drive, okay, so that means Dan is traveling, okay, so he's traveling a distance of 42 with the speed of x plus 0.4. So I'm going to pull that over x plus 0.4. Remember, whenever I see binomials, I always put brackets. I don't want to make mistakes. So that's what it looks like. In terms of the drive for Sue, Sue is also driving 42 kilometers, and she's driving with a speed of X kilometers per hour. Okay, so that's great. That's my time in terms of the drive. Okay, so the reason I wrote it so that I had some space was because I need to talk about the stop. So how long did they both stop for? So think about that for a second. How long did Dan stop for and how long did Sue stop for? Okay, let's look at that. So you're looking at the part that's highlighted in blue. So Dan stop for, how many hours is that? 1/2 hour. So that's 1 over 2. So 1 over 2 is 0.5. So 0.5 hours. Okay, so what about Sue? How long did she stop for? Well, think of it this way. She didn't really stop during her ride, but Sue's driving, she's driving. Dan is stuck at the back. He's getting his car fixed. Sue arrives first, and then Sue is waiting, right? And then Sue is waiting for how long? Sue is waiting 15 minutes, and then Dan arrives, right? And so I need to figure out, okay, well, 15 minutes is what in terms of hours? So, um, so easiest way would be to think of it as, okay, in 1 hour there are 60 minutes. Okay? And in chemistry we call this the mole train. But I always put the unit I want to get rid of on the bottom and the unit that I desire on the top. And so it's equal to, and in this case I don't really need it in fraction form. When I do that I get 0.25. And so that means Sue waited 0.25 hours at the end. Okay, so this is one strategy of how you can solve for this. And the table helps you kind of organize, and you might make it look, you might have to rearrange this diagram. Well, you might need to use different equations of it depending on the situation. But in this case right now, well, we need a less out of time, and so we kind of broke it down this way. So how is this breakdown going to help us? Well, they both travel 42 kilometers, and they so they drive for a certain amount, they stop for a certain amount. They drive for a certain amount and stop for a certain amount. That means that Dan's total time is going to equal what? Well, that it should equal Sue's total time because they will both eventually arrive at the final part, the final destination, final stop at the same time. Okay, because remember, Sue's waiting for him until he arrives, right? And so that could be my setup. And so what I have is, well, Dan stopped for 0.5 hours, and then the rest of the time he was driving. And Sue stopped for 0.25 hours, and then she traveled with for a time of 42 divided by x. Okay, basically this is the stop, and that's the drive. Okay, so we want to make sure that we're putting things to one side and putting things to the other so that we could try to simplify. So I have 0.5 plus 42 divided by x plus 0.4 equals 0.25 plus 42 over x. Okay, I'm going to subtract maybe the things on the right side, and then I'll get it to the left side. You could have chose any side. It should still work out. And so that means I have 0.25 plus 42 over x plus 0.4 minus 42 over x equals 0. So this reminds me of the rational expression unit from Unit 2. Reason is because I see these rationals, right? And to properly simplify them, I need the LCD. And I have some LCD rational expression examples on this side that you can refer to. So that's a very simple version of it. And then the other version. But basically, what is the LCD? Well, in this case, it's going to be, well, I see two denominators, the two main denominators, x and x plus 0.4. And if I multiply those, that is going to be the LCD because just like I have for this example, if my LCD is 6 in this example, and my LCD is going to be the x and the x plus 0.5, the multiple of the two. I'm going to multiply the two. So I have x times x plus 0.4. Okay. So zooming in, that means I need to multiply the top of this by x times x plus 0.4 and this by x and x plus 0.4. The second term already has the x plus 0.4, so I just have to multiply it by x. The third term has x on the denominator, so I just have to multiply by the missing parts on the numerator and denominator. And the next step I just have the denominator of x times x plus 0.4 on the bottom because everything's going to consistently have that denominator, just like I have here. And then, so I have 0.25 x bracket x plus 0.4 minus 42 bracket x plus 0.4. And I definitely missed the middle part, which was plus 42x and then minus 42 bracket x plus 0.4, all of that equaling 0. So I am going to have to do distributive property. So right here, I have 0.25x squared. That works out to be 0.x plus 42x minus 42x and then minus 16.8 all over x bracket x plus 0.4 equals 0. Collecting like terms. I see these are like terms, but they actually cancel. And then I don't see any more like terms. So I have 0.25x squared plus 0.1x minus 16.8 divided by x bracket x plus 0.4 equals 0. At this point, I'm going to ask you, what is the denominator on the 0? Any number has a denominator of 1 if it doesn't specifically have a denominator. So interestingly enough, although the rational part might have scared you a little bit, when you're trying to go solve for the x, we find that, oh, look, we can cross multiply. We can cross multiply. And when we do that, the denominator on the parts on the left kind of like disappear. It's like this original equation does have some restrictions, but in terms of solving for x, I just have this after my cross multiplication step. All right, so you see a bunch of decimals and I need to solve for the x, and I'm not remember solving for any vertex because they never mentioned max or min, right? I'm simply solving. And so that means I have 3 methods of being able to solve, right? Maybe I could bring that back, that image, to remind you. And so which one are we going to use? Well, we can't factor because we have all these decimals going on. And we don't really want to get it to the vertex form if we don't have to. That's a lot more work in this situation because it's not already in vertex form. So I'm going to try this method, quadratic formula. So I'm going to bring this over and then use the quadratic formula. So I'm going to say decimals involved. So x is equal to. So plug that all in into the quadratic formula and you should get negative 0.1 plus minus square root of 16.81 all over 0.5. When you do that, so you take the positive version and then the minus version, so minus 0.1 plus square root of 16.81 divided by 0.5, you should get approximately x equals 8. And then another solution you'll get is x is approximately negative 8.4. Okay, so these both are answers, right? They look good. Okay, so it doesn't because in this case, we're not talking about positive and negative integers or numbers. We're dealing with speed. You cannot have negative speed, right? It doesn't make sense. For any of these word problems, you need to double check and see if it makes sense, okay? So negative speed doesn't make sense. We have to always get rid of that one. If there is one, that doesn't make sense. Okay, and so we need to write a conclusion. And so therefore, Sue's speed is 8 kilometers per hour. And what's Dan's speed gonna be? Well, I'm looking back at the chart and I'm looking right here. Okay, and so Dan's speed is simply 0.4 higher than 8 kilometers per hour. So, and Dan's speed is 8.4 kilometers per hour.